and welcome to another coding walkthrough. Today we're going to look at a fairly common technique, which is supplanting some functions. Well, at least that's my term for it. This is when you have an idea about a change that you'd like to make, and you kind of may not have written any code yet. You know there's a place where you are doing some things in your code and that it will need to be replaced by something far more sophisticated. So what you'll need to do is put in some supplanting functions that will take the place of what you're currently doing, and then inside those new functions you can call whatever functions you're then going to write. So initially you'll probably create the new functions, and in where you were doing something you'll put calls to these functions, and you'll move the thing that you were doing into those functions so that you're not actually making any change at this point. The idea is that later you'll come along and you'll expand what those functions do in the way that you kind of had in mind. Now, the example I'm going to use here is from a real program, because that's my intention with these videos. I don't want to provide a simplified version, not because that's bad, but because it's not what happens in real life. In real life, you don't get a nice, neat little example showing you just the particular technique. In fact, what you have is messy, huge amounts of code, and it's in the middle of that you're going to have to do this supplanting of some feature by a way to then expand the feature later, and that's what we're going to explore. The program we're going to use here is my program called Folder Tree, which is currently on the screen. This is a program I've written in Python for doing large-scale comparisons and discovery of duplicated files and things like that. We're going to look at a particular part of the program that goes checking that things are exactly the same, and that part is called congruentry. It looks like this, and really it's just got an ability to say one particular path of where you'll get some files, compare it to another path, and particularly the idea there are trees of files there, compare those two and see if they're exactly the same. Now the program works at the moment, that's all fine, but actually it's a bit limited in the way that it works. I originally just hard-coded it to assume that the file names were exactly the same, that their file sizes were exactly the same, and the reality is what I want to be able to do with this is far more subtle versions of things. I might want to detect when the files are, well, they would be the same name, but one's in uppercase, one's in lowercase, that kind of thing. I have already added features into it for dealing with different character encodings, which is a kind of a complex subject, but relates to UTF-8 and Unicode and this kind of stuff. So there's a little bit of that ability in the program. It's a bit hard-coded, and I'd like this to all be far more flexible. At the moment, there's a couple of parts of the interface here where that gets dealt with. There, I've got some code character encoding settings in here. It's looking a bit cryptic. But really there's nothing here about file sizes, and I might, for example, want to be able to say for a particular comparison, hey, it's okay if the files are out by just a byte or two, or something like that. If they're basically almost exactly the same, then that's fine. I'll have to find a place in the interface to do this, as in the graphic interface here on the screen, but I will also need a way down in the program code to handle that, and we're going to look at a variation of doing that at the moment. So now I have to check my notes here. So the current method that's being used to handle all this stuff is that there's a couple of modules that I'm calling. So let's close the program now and go having a look at that section of the program. Do that. Up out of that. And we're going to have a look at the congruentry part of the program, which is here. Jumped us into the middle, so let's jump to the top of the code, and in particular we want to see the imports here, because the import that we're interested in here is this one here. So this is a fairly standard Python module that I've been using to do quite a lot of the bulk of the work of the file comparison. So as you can see, it's actually called file CMP, and I've imported it and given it an alias of import file CMP. That's nice, because it actually means it's quite easy for me to find where the things are that are using that module. So I can just go and bring up my search, go looking for that, and there's one spot there. So there I'm using a feature of that module called dir compare, directory compare, dir comp, which gets passed to paths. So that's one place where I'm using this. Here's another one. This time the call is to something that's comparing files. That's multiple files. So it actually gets passed in a path and another path and some other controls. What else have we got here? This one's file compare.cmp, which just compares two files. That's all. So that's this one here. You can see it's being passed either two different file names, and there's a setting for whether it should do that shallow or false, that kind of thing. And what else have we got? That's just a comment. Another call to the file compare one there. This file compare is just called CMP in that module, and that's it. That's the ones. So the issue here is that there's some aspects of how that works that I cannot change in my program now. I can't sort of do that comparison and then check things afterwards because I need differences inside those comparisons. Now at the moment I haven't written the replacement for how those comparisons would work. Well, actually I have a little bit. There's actually a module over here called comparatory where I've been writing code for that. It's not working yet. I mean, well, it's there, but it's not doing what I need it to do yet. So really what I'm doing is I'm preparing for when those functions will be available. And so I want to do something to get my congruency module ready to use that one. But until then, I want to just keep using the same functions it's been using. So really what I want to be able to do, we can always pick any of these places where I'm using the imported function. Actually, I want to have a different call there. So instead of doing that, check congruent is the Boolean result of running that thing. I want to create a new function, and it can take the same parameters as that, and at the moment that new function will just pass it through to the imported file compare function, and the same goes for the other ones we saw. So so that's really what I want to construct here. And because I have cheated a little bit here, because I've written up notes to guide me about these things, I have knocked up somewhere here the idea of what the files might come to be. So let's have a look at what those might be. I'm just going to come into the editor here. Actually, we might just go to a new file quickly here and just post in from my notes. So we saw that there were 3 different functions I was using there. I want to do slightly neater names inside my program, and these are the names I've come up with. It looks a little bit cryptic. So FCMP, that's going to be my file and folder compare name, and I'll call one of them for 2 directories compare get object. I'll explain the get object a bit later if we get to that. Then the second one for directories compare the files in them. That's what that second call did. And the third one that we saw there, which is just comparing 2 files, that'll be FCMP for 2 files, compare contents, get bool. Just get back a true or false. So I'm kind of writing those in a way that I feel is clear. It sort of says that all 3 have the same prefix, the FCMP. All 3 of them say for what they'll get passed, and they say get something back. And that's going to be the plan of how those functions will look. Now that's just the names that I've scratched up there. What will the functions actually look like? Well, for one thing, we need them to look like the same sort of parameters that are in the calls that are currently being used. Now I'm actually restricting myself here to just the parameters as I'm using them in my program. Actually, if you were to go and look at that module that I'm calling, it has a whole lot of other options that you can pass extra parameters. That's fine, but I'm not using those at the moment, so I'm just going to make my functions for just those. So here you can see I've knocked up 3 lines doing the defined function. You can see as the highlight goes over, the same name. But here I've actually sketched up the parameter sets. So for the first one, getting past a path, a second path, path B, and a value of shallow or not. And then for the second one, we've got something similar. And for the third one, now for these, I both looked at my program, but also went back and looked at that other module to see actually what those parameters were at least defined as. So that's kind of good, but actually that's not code that we can drop in yet. At the very least, I would have to do that, colons at the end of these, and come in and do, actually I think you can just do pass, and that would be then code that I could put in there and would actually do something. But I have already prepared a version of that. So I have written up notes for this little run through, which will, one reason you'll find that if you look at those, this will make a lot more sense. So here are my mocked up version of these. These would actually be something I can drop into the code as it's currently sitting there in the module. So we have a define, the name, the 3 parameters, and actually all I'm doing here is basically returning what we would get back from calling, as you can see here, that imported file compare module. In the case of the first one, calling the dir compare. In the case of the second one, calling cmp files. And in the case of the third one, calling cmp. Those were the 3 calls that we found when we looked through the module earlier. So actually this alone, at this point, that should work. I should be able to go and drop that in. It won't affect anything else, they'll just be functions. And I should be able to go over to congruent tree. And now kind of there's an issue about where in the code to put them. I'm going to scroll, I'll actually let this scroll. So you can see going from the top, I do have sections for bits of code that are not the main code, but are used further down. Support stock, support custom, support emulation. Yes, I've got an empty section there that I have set aside for abstraction for later changes to library calls being used. There you go, that's exactly, I wrote that a year or so ago. So I've been sitting there waiting all this time. So I could paste that in, and if I do a run, that should, no? Oh, okay. Now, one thing I should say here is that all the code that I'm pasting in, I wrote over in just a text editor, not in the IDE at all. So frankly, I have not had a chance to pick up syntax errors yet. I just thought ahead about what I was going to do, and as you can see, missing the colon at the end of the function definition line. Let's do those. All right, that's now happy. Now, of course, nothing's happened yet, but I could, at this point, start going and finding where I was using these and do the replacements. So that should be fairly easy. So for this first one, I'll get that name in the clipboard, Control C, come down to the call that it's going to replace further in the code, bring up my edit in search replace mode. So that's that. And we're going to replace it with the new name. Let's go find where that is. There's one of them there. Do replace and find here in this editor. That was the only one for that. So that's fine. We'll just jack back to the top, come page down until I see my emulations again. Here we go. So I'll get this one ready in the clipboard, Control C. I want to replace usages of that with that. Find, there's one, and it's the only one. Come down, find the third one. Here it is here. Put that into the clipboard. Put that ready for replacing. Paste in the new name. Find. Now I think we had 2 of these. One. Ooh, what am I doing? Might leave that comment there quoting that, because I don't remember quite why I was talking about that there. That comment may need to move into where the emulation's occurring. Alright, and that was the only one of those. Now in theory that should pass. It does. And look, I could probably now go testing that. Really, I can't think of any reason why that wouldn't work. I've really just matched through and made some pass-through functions, really. So on one level, I've made a fairly safe change, and actually really now I could bring up my code monitoring in Git GUI, do that for folder tree, let it pick up the change. Okay, there's other things been going on, but congruent tree here, we should see we've added three things into the support emulation section, showing up in green there, and we can see the replaced call spots further down in the code, and so I could commit that. Oops, does help to put a message in. Introduced supplanting functions, and commit that. There we go. Trying to think what else while I'm quickly here. Alright, that looks like I was just tidying up there. I'll just commit those through. All references. Because I had gone through the code looking to find where else I seemed to be using that file compare module, but I had actually shifted everything to be in just the congruency module by then. Alright, so those changes are locked in. The program should work. Look, really I should go away and now run lots of tests and just check that, but apparently I'm not going to. So that's kind of our first round, is just to go and put those in. The next round is actually start doing something instead of those functions. So let's see what we might have here. From my notes I can see that I don't actually intend doing anything different for the first one. However, the second one, the directory compares get lists, I actually have written a replacement. So this is really not so much to show you the detail of this, but to show you that how that works. Actually, I'll go to the third one. That's the simpler one. Just clip this over. So we're looking here at this third function here, where really all I had done was take the three parameters and pass them through. And actually, I can see a mistake straight away because the highlight is not matching. So up here, path B, we can see in the first line of the function, on the definition of the function, and there it's in the call to the other function. Here, P path file A, no, it's not highlighting. It's the same. It hasn't got the P at the front. So let's just fix that. And the same is true for the P shallow. Yep. Alright. And actually, get going. I'm just going to pick that change up and commit that. Fixed typo in the planting function, and commit that just so that's definitely understood in there. Alright, now come back to where I had a deeper version of the replacement for this function. So this is the one where we're just comparing two files. This one, f compare for two files, compare contents, get boolean back. So here's my other idea about how to replace this. So let's see what I was doing there. Not a huge amount different. Looks like I've just put in a little bit of logic there. Ppath file, okay, looks like I've got the same quotation problem there. Let's bring this in, that goes there, that one goes there. So this is an example where I had written up pseudocode. I mean, I had an idea that hopefully it shouldn't have been too wrong, but clearly it was not exactly right. And then creating that. So in terms of what was going on here, actually this line is pretty much there. The same call there is almost the same call that we have up here as a simple one through, but actually it looks like I'm playing about with the shallow feature. So past the top one here, passing in with a default of false. Actually we're saying here, do the comparison with shallow true. So in other words, that's not comparing every single byte of the files, it's just the thing we're calling here. We'll go and just check if the file says it's the same size and it's the same date, then that's good enough. It's not going to compare every byte in there. And then based on combination of what it just found from that as to whether they matched and also whether we said we wanted shallow, it might then go and do false for shallow, which actually means do the byte-by-byte comparisons in there. So just a slight extra bit of logic in there, so it's a bit maybe clearer for me about what that's doing. It's also bringing back two different booleans now. Now you might remember my function I had in here, getBool, was returning one boolean. If we went, in fact, because we haven't changed it, if we go and look where this function, this supplanting function, is now being used, we'll find that it is it's the place where it gets called is picking up just one boolean. But actually, what I've done in this rewrite is return two booleans. One saying, were they exactly the same, whether we did it shallow or not, and the other one saying, in case we did go checking the byte contents, were those the same? So it's returning two booleans. So actually I now do need to go and change where that call is. Now of course at the moment I've got two versions of the function both sitting here, they're both the same name. And because I've got this stuff clipped over, and I've already done a git commit for it, so it's in the history, I'm just going to delete the first version of that. And we've got this one in here now. At this point, the code actually should crash at some point because there's going to be a bit of code that's going to be expecting expecting one boolean back, and it'll get two back. So we now need to go and fix where we're using this. So I'm going to go searching for this function call. There it is there. So in fact, we now need an extra boolean in there. Now I could just cheat and just do iBool. Without caring about how we use it. Search for more presences of the function. There's another one there. Bool, like that. Alright, well that's our two calls for that function. That actually means the code would now run okay, because I think the first boolean is basically the same as what it was doing before. It's just that now, depending on what happens, we'd like to know, did it actually check, did it, in finding they were the same, did it do that by actually checking the contents or not? So that was the idea of that change that I had in mind. This should now work and should run in that sense. So that's that one. So this gives you an idea of how to change the function, and then I'm kind of free to start changing what the function does, and I can now, in my other parts of the program where I'm calling these things, like here where I'm calling now my function, if I want extra subtleties about what it does, compared to what that module I was calling does, I'm free to do that. So I've actually introduced an ability to give myself a lot of freedom. And in the longer term, what will happen is that when I have written my new module, the comparatory module that I pointed to earlier, they'll say, well, I'm writing that to provide complete replacement for the standard module that I've been using. I can just come and change the calls in here to use that. In fact, I can even probably put myself in a little switch in here that I can then just easily flip between the standard module and then my new one as I'm testing that, and see, check that they both work the same, or that. So I've got an abstraction layer, if you like, that I can now find very useful. I'm just going to clip in the middle one of this, my replacement for that, partly because I wrote it as pseudocode and I'm interested to see how horrible it is. And I wrote it a while ago, so I'm not going to recognize this straight away. But also to give you an idea that, I could have a fair bit of sophistication that I'm adding here, even before I go to use my own new module that I'm planning to write. So for this section function now, I'm just going to replace it straight in here. There it is there. That's a bit more complex again. It's actually got two deeper functions defined inside of it. One of which does nothing at the moment, which is kind of interesting. That's planning ahead a bit. And you should find that passes. The question is, did I do things correctly here? Now I can see the path A down there, the P shallow is passing through. That's looking fine. Ooh, okay, that didn't match anything. Why? Path file. Oh, I see. That's because it returns nothing. Actually, the thing I should patch there is that one. Yes, that's fine. And probably that one there. That matches in there. That matches in there. That's fine. All right. And at this point, I'm probably ready to go actually start seriously now doing the next round of coding and try and remind myself exactly why I wrote this the way I wrote this and what it was doing. I can see a few clues in there. That's not a concern for this video because this is just to say, here's how you go about doing some supplanting functions. And again, I do want to point out that, you know, I've honed in on exactly where in the code I'm dealing with here because, you know, I had already worked that out. But, you know, there's a huge amount of code in this program now. But the supplanting idea is, you know, something you can come in and do is quite of a narrow focus, really. You kind of know what you're going in. It's like, you know, a surgical operation to go in and sort of pull one thing aside and replace it with something else and give yourself a newfound flexibility. Well, that's all for that. Hope you found that useful. The notes for this, which are frankly far more comprehensive than I've spoken at this time, I kind of wrote out quite a bit, will be available linked from the video, hopefully, before long. Cheers.